Okay, welcome to 7.2b. This is for Wednesday, April. What is tomorrow? I think the 5th. This is really for 7th hour. For Wednesday, I have a game today, so leaving at 1:20. Bus leaves at 1:50. So 7th hour, this video is for you. Hopefully everybody understands everything. Ask questions. Come seminar on Thursday if you need to. Otherwise, Friday as well, okay? All right, so let's get started. The first one says, well, the directions say simplify each radical. Okay, so it says simplify each radical. So I really want to look at these and see what I can simplify down. Well, the first thing I notice with this is it has a square root of 3, a square root of 3, and a square root of 3. Meaning just like if it was all x's, right? X's, y, z's, doesn't matter what variable. If they're all the same, then what do I do with the coefficients when I'm adding or subtracting? Well, I'm just adding or subtracting the coefficients, correct? My, in this case, radical, which is treated just like a variable, is treated the same way. So if I have 2x minus 2x, well, that's no x's left, right? Or 2x plus 2x, that's 4x. In this case, I have 2 square root of 3 minus 2 square root of 3 minus square root of 3. In essence, since all of my radicals are the same, I'm really going 2 minus 2 minus 1. Well, when I look at that, 2 minus 2, well, that's nothing. What do I have left? A negative 1. So the reality is I have a negative square root of 3 left. Okay? The next one, 3 square root of 5 minus 3 square root of 2 plus 3 square root of 2. Well, I don't have the same radicals here. I've got a square root of 5, a square root of 2, and a square root of 2. So I do have 2 square root of 2's, but I have a square root of 5 there, right? Radical 5. So when I look at this, I'm just going to bring down the 3 square root of 5. There's nothing I can do with it yet, okay? Now I'm going to deal with the negative 3 square root of 2 and the positive 3 square root of 2. Well, what's negative 3 plus 3? Another way to say that is 3 plus a negative 3. Well, there's nothing left, right? So the reality is this right here gives me 0. So 3 square root of 5 plus 0, well, really, that's just 3 square root of 5. All right? Let's do some more. 2 square root of 3 plus 2 square root of 5 plus 2 square root of 5. That's what I have there. I'm going to turn this so you can see me just a little bit better. Okay, that might be a little bit better angle. So 2 square root of 3 plus 2 square root of 5 plus 2 square root of 5. Well, I only have 1 square root of 3, so I'm just going to bring it down. And I've got a 2 square root of 5 plus 2 square root of 5. Well, really, that becomes 4 square root of 5. I'm adding the 2 coefficients since my radicals are the same. Now, I look at this. I have a 2 square root of 3 plus a 4 square root of 5. Well, I can't add, remember, just like with variables, I can't add apples and oranges or x's and y's. I can leave them together, right, with a plus sign or minus sign in between them. But I can't say 2 oranges. I would say 2 apples plus 2 oranges. So in this case, I have 2 square root of 3 plus 4 square root of 5. This is my final answer. I can't be any more simplified than that. The next one. Now, in between this one is multiplication. What I can do is multiply radical by radical and its coefficients by its coefficients. So in this case, I really am saying that I have a negative 4 square root of 6 times 1 square root of 15. And I'm emphasizing this 1, which I normally wouldn't, but I'm just doing it for effect today for the notes. There is a 1 out here. Well, when I have radical times radical, I want to multiply the coefficients first and then the radical by the radical. So negative 4 times 1. So negative 4 times 1 is a negative 4. And then a radical 6 times a radical 15. Well, 6 times 15 is 90. So this is a square root of 90. So really I have 4, and that's a negative 4 square root of 90. Now it does say simplify. Can I find a perfect square that goes into 90? Well, the answer is yes. I know that if I break this down, the square root of 90, into a perfect square and a non-perfect square, I can look at the square root of 9 times the square root of 10. And remember, that's multiplied together. Now the big question I'm going to ask myself, if I know I've done the highest perfect square, is does the 10 have a perfect square left in it as one of its factors? Well, the answer is no. So I know that this is simplified, and this is the biggest perfect square I can pull out of 90, and this is simplified as far down as I can get. So really this is saying negative 4 times the square root of 9 is 3 times the square root of 10. Negative 4 times 3 is negative 12, square root of 10. And that would be your simplified answer. That is far down as we possibly can go. All right. Now, remember, you can pause these at any time. You can repeat, go back, go forward, pause, do whatever you need to do to make sure that you're able to get exactly what you need from these videos. We're about 7 minutes in. We're going to probably be a total about 12, 13. So really not a big, long video for you. Okay? All right. Looking at this one. Now, we have learned how to simplify bigger radicals, right? And with variables at different levels. So we're going to have to do this, but we're going to have to multiply them first. Okay? So when I look at this, I've got a 5 and a negative 2. Well, I want to multiply the 5 and the negative 2. Well, 5 times negative 2 is negative 10. And that's going to be multiplied. And I'm doing this multiplication for emphasis. Remember, that really is going to be a negative 10 square root, right? That negative 10 outside of it just means multiplication. But I'm really doing this for effect because I need you to see it. 6 times 15, well, we just did that. That's 90. And n third times n to the third. Base times a base, I add the powers, right? Add the exponents. Base times a base, I add the exponents. N to the third times n to the third becomes n to the sixth. Now remember, this says simplify, right? So my negative 10 stays out front. I'm going to switch colors. So negative 10 stays out front. It's going to be times. We just did this one, the square root of 90 breaks down to the square root of 9 times the square root of 10. Am I trying to simplify? And as we did on Tuesday, n to the 6. Is n to the 6 a perfect square? It is. So I'm just going to go ahead and bring it down. From here, eliminate the ones that are perfect squares. So negative 10 times square root of 9 is 3. So I've used that one up. Square root of 10 is simplified as possible. So I'm going to leave it alone. N to the 6. Well, the square root of n to the 6 is n to the third. That one eliminates. I've already gotten rid of the negative 10. So the only thing left up there is the square root of 10. So this is negative 10 times 3, which is negative 30. N to the third, square root of 10. That would be your final answer on that one. Okay. Last but not least, I have a negative square root of 15 times, and it's distributive, right? Distributive times square root of 6 plus square root of 10. So as I look at this, I need to distribute both of those. So the negative square root of 15 times square root of 6 and, or plus, the negative square root of 15 times the square root of 10. That's what I'm looking for. So as I do this, the negative square root of 15 times 6. Well, that is, what is that? That's our good old lucky square root of 90 plus a negative 15 times 10 is 150. So now, I need to simplify these down. Well, negative 90 is negative 9 times 10, and the negative stays out front, plus 150. Well, the perfect square is 25, right? 25 goes into 150 6 times. We've done this one a few times. So this is the square root of 25 times the square root of 6. So let's break this down. Square root of 9 is 3, so it's negative 3 times the square root of 10. I know I've eliminated that. That one comes down. Plus, square root of 25 is 5, so negative 5, square root of 6. I'm as simplified as I can get. That would be my final answer. Now, I could put it in simpler terms and say negative 3 square root of 10 minus 5 square root of 6. But really, that's just semantics, because plus and negative is the same thing as saying minus. All right. Any questions, please feel free to ask. I'll be happy to answer for you. We are right at 12 minutes. Have a great day.